So extending on what we did that first day with exponents, we really want to take some more complex problems and see how we can simplify them, understanding our properties of exponents. So remember our rules of exponents. First and most important is they have to have like bases in order for us to play with them. We add exponents when we're multiplying these bases, and we subtract exponents when we're dividing these bases. We flip the exponent when we flip the base when there's a negative exponent, meaning if the negative exponent is in the denominator, we can flip it up to the numerator, and if it's in the numerator, it flips down to the denominator. So the questions that we're going to play with today are more like you'll see on the SATs. How can we take this expression and boil it down to the number 4? We have to understand that we have exponents here. So the first thing that should come to your head is, well, I can't do anything with this problem until I make their bases the same, so that way I can combine them. And this is going to lead us right into our next section of logarithms. But I'm getting ahead of myself. So I look at this as base 2, this is base 4, and this is base 1/8. Well, I can rewrite all of these in a very easy base 2. In other words, this is already base 2. Good for you. You get to stay there. But I can rewrite this 4 as 2 squared. And then it's still being raised to the n plus 1 power. And this 1/8, that's right, it can be written as 2 to the negative 3, and then that's still being raised to the n power. I'm going to clean this up because we have some powers being raised to powers. Well, this one doesn't change, but 2 to the second raised to the n plus 1 means we still have a base of 2, but then our exponents become 2n plus 2. Because remember, when we raise a power to a power, we end up multiplying. We can extend that to here. The base is 2. A power raised to a power, we multiply, and that's negative 3n. Now we're still trying to see if all of this can boil down to that simple number 4. Well, now that we do have the like bases, we can combine. And right now we're multiplying, so that means we can add these exponents together. So if I come over here, this is what my brain should see. I have an n, I have a 2n plus 2, and I have a negative 3n. If I add all that together, well, n plus 2n is 3n, minus 3n, that just leaves me with the number 2. Wow, I can rewrite all this as base 2, and my exponents all got combined together to 2, and joy of joy, 2 squared is 4, which equals 4. So we're just going to continue playing that, and we want each one of these answers here to be rewritten as a power of 10. That means our final answer has to be 10 raised to something. So we're multiplying here. So this wants us to take 10 to the n and multiply it by 10. Well, our first law, I have like bases. So now I can combine exponents by adding. The base is 10. I have an exponent of n from the first guy, and then 10 is really raised to the first power. So this can be rewritten as a base of 10 raised to the n plus 1 power. Okay, this one is saying take the square root of 10 and multiply it by 10 to the n. So 10 square rooted means 10 to the 1/2. And I want to multiply that by 10 raised to the n power. I have like bases, awesome, so it's a base of 10. And when I'm multiplying, I simply add exponents together. Now it doesn't look nice, but we're doing what the problem said. Express each answer as a power of 10. Square 10 to the n. Oh, that's easy. We just have a power raised to a power, so we multiply. This is 10 to the 2n. Not bad, not bad. Let's see what's going on here with D. Divide 100 times 10 to the n by 10 to the 2n. Well, I'm going to write this out. I'm going to take 100 times 10 to the n, and they want me to divide that by 10 to the 2n. Well, there's two ways I could do this problem. And of course, I'm going to show you both ways. Here's the first way I could do it. I could take this 100, and rewrite it as 10 squared. And then I still have 10 to the n, and that's all getting divided by 10 to the 2n. I can combine the numerator to make it 10 to the 2 plus n, because when I'm multiplying, I add exponents together. And I still have on the denominator 10 to the 2n. Now, I've got like bases. Awesome. I'm dividing, so all I have to do is subtract the exponents. Well, 2 plus n minus 2n gives me 10. And this is what I'm thinking in my head. 2 plus n minus 2n. I get 10 to the 2 minus n. All right, so what's the other way I could have done it? Could have done it this way. I could have left that 100 times, whoops, let me rewrite that. 100 times 10 to the n over 10 to the 2n. Now remember, multiplying means or. So I can take this 100 or this 10 to the n to divide it by 10 to the 2n. So I'm going to choose to take, obviously, these two and divide them out. All right, so when I divide that out, I get 100 stays, 10 to the n minus 2n is 10 to the negative n. And then it said, well, rewrite as a power of 10, and this is not a power of 10. This is a power of 100 times a power of 10. So then I can rewrite the 100 as 10 squared times 10 to the negative n. And then when I'm multiplying, I add exponents together, and voila, I get the same answer. All right, so the last one. I want to spend a little time on this last one here. I want to show that 10 to the n can be obtained by taking 11, multiplying it by 10 to the n, and minusing 10 to the n plus 1. Wow, it didn't look hard till we threw that 11 in there. All right. I know you're going to say, I would never think to do that, but it takes just some practice here. And this is the first thing we want you to see. That this 10 to the n plus 1 can be rewritten as 10 to the n times 10 to the first. Because we could break apart and say, well, if we were multiplying, that's how these exponents got added together, because we must have been multiplying. Now, here's that word that's never going to leave your math vocabulary ever. It's factor. And I can factor out a GCF here. What does each term contain? A 10 to the n. So if I factor out that 10 to the n, I'm left with an 11, a minus sign, and a 10 to the first, which is simply 10. 11 minus 10 is 1, times 10 to the n is 10 to the n. These are your favorite types of SAT, and those Math League questions that you do if you go over to Mr. Rude's Math League. They're kind of fun. I know, I'm a dork. I love it and I embrace it. See you tomorrow.